Okay, please, I think I should switch groups sometime in the next couple of weeks.
I like my group.
Wow. I heard strange noises over there. It was something like, it is necessary that I not need to quiet you guys down 23 times a day. Right? Yeah, my point exactly. All right. I'm tired. I'm getting old, you know that?
Me too.
Like 98 now.
I'm gonna get older in 11 days. Not 11 days. 6 days.
6 days.
I probably just failed math in math class.
Yes, I start qualifying for like cheaper meals at Denny's or something like that in a couple of weeks. They what? No, what'd you say?
Definitely. I would. I love Denny's.
You gotta be better places though. Not a huge Denny's fan.
I like the hash browns.
Lizzie loves IHOP.
It's not that good.
Sure, whatever you say.
It's not,
Anyway, my point is that it gets to be annoying sometimes when I have to go, shh, quiet please, shh, quiet please, and stuff like that. So let's not make me do that, okay?
Okay.
Let's start with homework. You guys had some homework on 5.4 that you may have some questions on. Yes? Well, he raised his hand, so I have to give him first. I know what he's going to ask for.
I would say 71 to 75.
You didn't have to do 75. My sheet wasn't. No. 63 to 73 odd.
Well, 71 to 73. Whichever one of those.
Come on, I'm good.
Yeah.
You guys have a preference?
71. 70 because that's LA.
I didn't really hear a preference.
73.
3?
Yeah.
Okay. ln of x. So you guys picked that because it's ln instead of log. Even though it makes absolutely no difference. Okay. What don't you like?
Different bases.
They are?
The four. Both the LNs are on the same side.
2.
What don't you like?
2.
There are 2 logs. That's what you don't like. If there was 1 log, we'd know what to do next, but there aren't. There are 2 logs. So how do we deal with that? Okay.
Use the log rules.
Use the log rules. Which one? Uno. Talk to me. X squared minus 2x equals 4, like that? Well, I'm just saying what I'm hearing. So if people are... Okay. We'd better, once again, we'd better say things correctly. Because, yeah, exactly. Attend to precision. ln of x squared minus 2x. I like that much better. Okay. For people on a quiz that puts something like remember that problem on the quiz?
Yes.
Well, that was part of it. There was more to it than that.
Yeah.
Okay.
Oh,
And do you remember that problem? What should it have said?
Log base B.
Log base b of x. So you see why I'm saying what I'm saying? Because this is what I always see year after year after year. I'm seeing less of it this year, which makes me very happy. But that's why I talk about the precision and the saying the right things and everything like that, because it's very easy for that to turn into that. Okay? And we don't want that to turn into that. We want that to be that, and we want that to be erased. Capiche? Okay. All right. We're happy with that? Okay, now what?
Let's try and solve for
yeah.
x.
Exponential.
Solve for x. That's the problem. That's what we want to do in the whole problem.
Exponential.
Set x.
So if we don't know what to do,
Change
change
form.
forms. So tell me what to write. E to the fourth.
Equals x squared minus 2x.
Sounds good. Good news. We went from one log to no logs, so that is good. Bad news.
E.
Yeah, but what does e to the fourth? What is it?
A decimal.
It's a number. Yeah, it's just a number. It could be 6, it could be 22, it's just a number. So, if this were a number, what would we do?
Move it to the other side.
Move it to the other side.
So you can do,
So that it's equal to 0. And what's our goal when we set it equal to 0? What would we like to be able to do here? Factor. Can we factor this? No, because e to the fourth is just not a good one.
You said.
Nah, we don't need to. What?
No, I figured I was gonna ask why the e's negative and then I forgot to switch it.
Gotcha. Yeah, I moved it over, but then I switched sides because I like the stuff on the left side a little better. So, since we're not going to factor, we have two options, right? Option 1 is quadratic formula. Option 2 is take the square. Which way is better here?
Quadratic.
Quadratic's never better unless you absolutely have to, because of just the ugliness of it.
Completing
Okay?
the square.
Why is completing the square nice here?
Number?
What's even?
2.
The 2 is even, and
The exponents are even.
there's no coefficient of x squared. X squared's by itself. Those are good things. I promise you, it's easier to complete the square than to use the quadratic formula here. Go. Yes, sir.
Why did we move it over as that if it was already?
Because, like, if I'm doing this, I look at this and I go, if I move that over, it's not going to be factorable, so let's just leave it like this and go with it. So that, but I moved it over so that we could see what we were looking at. And now we make the decision to do completing the square, and what's our first move in completing the square? Clear the constant, so we're going to take the e to the fourth and just move it back to the other side like it was up here, what Matt's talking about. I believe that's what Matt was talking about, is that right?
Yeah.
Okay there?
Okay.
Now what?
Take the half.
Take a
So tell me what to write.
-1.
Minus 1,
Plus 1.
plus 1,
Plus 1.
plus 1. Left side. By the way, in one of the upcoming steps, almost everybody in the class is going to make a mistake. Okay? So think about this one. Try to not make that mistake. Let's see what happens. All right, I'm sorry. What do I write?
X minus 1 squared equals e to the fourth plus 1.
Okay. Next step. Everybody's very cautious now because they don't want to make the mistake.
Take the square root.
Take the square root
Both sides.
of both sides. Left side becomes x minus 1 equals,
Plus or minus.
ooh, good on the plus or minus.
E to the second.
E squared is radical 1.
E squared plus 1,
Oh yeah, 1. You can't do it.
like that?
Yeah.
You can't simplify that. It's just e to the fourth plus 1.
The square root of 1.
Has to be
But the square root of 9 plus 4 is equal to 5, right?
No,
Why isn't it?
because you can't the thing.
Because we can't take the square root of things that
Are being added or
are being added or
subtracted.
subtracted. This is not 3 plus 2. Just like this
Is not.
is not
the second
b squared plus 1. That was the mistake that most people make.
So now it's not accepting. Well, like, move them to. That's what I meant. And it's separate.
Is my.
Are we okay with this?
Yeah.
Does everybody understand why we cannot take the square root of the right side?
Yeah.
Okay, what's our next step? So what do I write?
X equals plus or minus
1 plus or minus the square root of e to the 4th plus 1.
Wow.
That was fun, wasn't it?
So far.
but we're not done.
We're not? Why not?
If there's a right minus e to the
There are
fourth
two
plus 1
solutions.
wouldn't work. Yeah. That's well.
E to the 4th. Anybody know?
It's like 54 something.
Like 16, right?
In the 50s range? So plus 1, still in the 50s. The square root of something in the 50s is between.
I don't know.
About 2.
No, hang on. Stop. Nobody say a word. Think to yourself, you got about 20 seconds. No, just sit, don't say a word. You have about 20 seconds to answer the question silently to yourself, and then we're going to ask in a minute. The square root of something in the 50s is between 20 seconds.
Oh.
So the square root is 7 something, right? So if we did 1 plus 7, we'd get 8. Is 8 okay? Yes. 1 minus 7 would give us negative 6. Is negative 6 okay?
No.
No. So therefore, so what do I get rid of? I get rid of that?
Yes.
That is our answer. Oakley dokley? Uh, 71 is pretty similar. It's a log, so it's just different types of numbers, but it's the same type of deal. Okay, so the exact is that. And then plug in e to the 4th to get the decimal for it. Should be 8 point something, shouldn't it? 8.456. So we're on the right track. Okay. Ready? Cool. Sorry. Okay, we're going to talk graphs for a little bit. Oh, I know. Isn't it awful? We like draw squiggly lines.
Yeah.
That's terrible. It's so hard. All right, up here at the top, they give us 5 different model names, as they phrase it. We know some of them. So tell me, when I mention each one, whether we have dealt with it before or not. Model number 1, logarithmic.
Yes.
Yes. Model number 2, logistic. No. Model number 3, Gaussian. No. Model number 4, exponential growth.
Yes.
Yes. Model number 5, exponential decay.
Yes.
Yes. Okay, so we've dealt with 3 of them. Okay, we're going to look at some graphs for a second and see which ones we might know. So for instance, take a look at C right here. Okay, is C logarithmic, exponential growth, exponential decay? Exponential growth. It starts very low, comes over, it basically shoots straight up. Questions there, problems there? Okay. D. Logarithmic, exponential growth, exponential decay.
Exponential decay.
Exponential decay. It starts high, it comes down low, and it cruises right along the axis. Questions there? Cool. E. Logarithmic? You sure? You're honest, I appreciate that. Is E logarithmic? Why? There's an asymptote. Okay, remember that there's an asymptote there. And then remember what logarithms are. Logarithms are exponents. So the exponents are going to go up pretty slowly as we go further and further to the right. Like if we're saying log base 2 of something, log base 2 of x, then if x is 2, y is 1. If x is 4, y is 2. If x is 8, y is 3. Right? The x is the answer and the y is the exponent. So we wouldn't get to 6 on the y until x was at 64.
Oh, I didn't know what
I know.
number we were doing.
I know, I purposely phrased it kind of weirdly. But it's going to go up, it's going to continue to go up, but it's going to continue to go up very slowly. And so that's why it works this way. It goes up very quickly at the beginning, and then it turns and starts to go up very slowly. It's kind of like the inverse of the exponential growth and decay ones, isn't it? Yeah. And that's because they're inverses, which we'll talk about another time.
Another day.
What about F? Everybody pauses on this one because we've already done exponential growth, we've already done exponential decay, we've already done logarithmic. There's a fourth one, what do we put?
Logarithmic.
How many people think logarithmic? Good, that's correct. Why? There's an asymptote and it starts to level off somewhat. Is it still going up? Yeah, but
Not that much.
very slowly. Good. Okay. Here's my next question for you. And it's a multiple part question. So let's start with this. Let's say you had a fishbowl. Okay? How big's your fishbowl? Show me. Okay. So we got a fairly small fishbowl, is that what we're saying? Not one of those Mondo ones, but just stuff like that. Okay, got it.
She's thinking.
We have 2 fish in the fishbowl. Yep. But fish tend to multiply fairly quickly. And these fish, the number of fish in the fish tank will double every week.
Great.
So my question is this. How many fish will be in the fishbowl in 6 months?
How many days in 6 months? 6 and 4.
How are we going to figure that out?
24 weeks.
How many fish?
48 fish.
Huh?
48 fish. Not 48 fish.
If it doubles every week, how many would be in after week 1?
Oh, 50 fish.
4. What about after week 2? 8. What about after week 3?
16.
16. What about after week 4?
32.
32. Huh. be a lot of fish. How would we calculate the number of fish? Okay, so you can't just give me the general idea and make me come up with the rest. I want you guys to do that.
Wait, how many weeks? Or how many months?
6 months. Or 2.
See? I'm thinking we started doing one.
That would be a neat trick.
Oh, then we have a. Oh, that makes more sense.
We just got that.
So, once again, we have 2 fish. The number of fish in the fish tank doubles each week. How many fish are in the fish bowl after 6 months? 16 million? 6. How many weeks did you say? 26 weeks. 57 million, isn't it? Wait, he said no. He said no, it is.
There's 4 weeks of
Have some faith in me here. Because they're not exactly. Tell me about the fish in the fish bowl. There's a lot. How many fish are in the fish bowl?
I like to fish. I had a big
67
fish
million.
bowl, and nobody listened to my big fish bowl. I know.
Is there a problem there?
It's not a bowl.
What's the problem?
My little fish bowl.
That little fish bowl can't hold
Hey,
67
I
million
suggested
fish.
a big fish bowl.
A big fish bowl couldn't handle 67 million fish. I'm not sure the ocean, no, I'm just kidding. Tempe Town Lake couldn't handle 67 million fish. So, okay, come back to me. So there's a problem. What the calculation that you guys made, which fit exactly with what I had said, was an exponential one. It was an exponential growth one. It was the function 2 to the x, right? Because you did 2 to the 26th, or you were going to do 2 to the 24th, or whatever. But you were doing the exponential function. And the exponential function works well to a limit for a few weeks. But it doesn't work long term. And that's because it's not actually an exponential function. It's what we call a logistic function.
I knew you were going to talk about it.
And we call it a logistic function, or a logistic function is when there is some type of limit on what can happen. Okay? Fish in a fishbowl. Population of the earth. Amount of money that the government owes or something like that. What's our national debt? Okay, all of these things have some type of a limit, and that's a logistic function. So here, there we go. So here's something about a logistic function. Okay? University of Central Florida was the second largest university in the country in 2011. Do you know what number 1 was? I think it's ASU. Good.
Thank you.
We can check it out, but I think ASU has more students than any other. ASU's certainly big. But anyway, not my point. I got to roll. The number of students that can be modeled by the function 60,000 over 1 plus 5e to the negative 0.12t, where t is time in years and t equals 0 corresponds to 1970. Now I'm going to tell you this right now, so just listen and breathe. I promise you that this is going to be a lot easier than it looks, because we do not have to create the function. They're going to give us the function, and all we're going to do is plug some numbers in. For the entire assignment, everything that we do today is just going to be plugging some numbers in. But one of the parts of the logistic function is even easier than that. Okay? And that is this. The fish, we said that there was some limit, right? In fact, they call it the carrying capacity. Okay? Up here, they talk about rabbits up here. Ultimately, the population of rabbits reaches the island's carrying capacity. The carrying capacity is the limit, and that's A. Well, where is A? in the function here? It's the numerator. This is the nice thing about a logistic function. The numerator is the carrying capacity, which is the limit. So, part, yep, you're not really going to have to use it, but I have no problem if you want to do that. Part C of this question, you just want the formula there. I slapped a little bit. I could probably get to see. Yep, there it is. What is the carrying capacity of the University of Central Florida main campus?
60,000.
60,000, that's it. So we like carrying capacity because it's very easy to find. It's right there and we're all set. They ask us how many students attended UCF in 1990. How are we going to do that? We could, but I can't tell exactly from that graph. Plug something into the formula. What would we plug into the formula? 20. Why 20?
90 minus 90.
Because it says t equals 0 corresponds to 1970. So 1990, t will be 20. So all we do is we make t 20, plug it into our calculator, and we're done. Okay? Part B says how many students attended UCF in 2010? Plug in 40 for t. Plug it into our calculator, and we're done. Part C says what is the carrying capacity of UCF? 60,000. We're done. That's what we're going to be asked in our logistic problems. Okay? That's all. Yes, sir?
Do logistics have to be like exponential functions with a limit, or?
It will look pretty much exactly like this. Okay, they'll all look exactly the same. We're not going to use them much. I wanted you to see what a logistic function is. I wanted you to understand what carrying capacity meant and why it might come into play. And then besides that, I want you to see one and plug in a couple of numbers. So that's all we're going to do. Okay. There's another one. Yeah, it's called Gaussian. There's Gaussian. Yes, Gauss, I believe, was German. So this is a Gaussian one. There's also one over here.
How do you spell it?
G-A.
Wait.
Oh, whoa.
Okay. A is Gaussian. What is B? B is logistic. It looks exponential for a while, and then it flattens out because the fish tank's getting overcrowded. Okay? So that's what a logistic one looks like. This is a Gaussian one. Gaussian, boy, that's weird, isn't it? It's kind of like nothing, 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 a lot. Nothing, 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 nothing. Right? Yeah. When did that happen? What could that be? Heart monitor. Cool. Yeah, definitely. The height of people in the United States. How many people in the United States are 2'4"? How many people are 9'8"?
I wish.
How many people are 5'6"?
I'm 5'3".
A lot, right? This is like a height type of thing. A few people down here in the 4 to 5 foot range, more people up here in the 5 to 6 foot range, some over 6 feet, some getting even close to 7 feet, and then really not anything after that, right? Okay, it could be that. It could be grades. Say the word grades and people freak out. You know, hopefully we don't have people getting 10s. Most people will be getting between,
Oh, I thought we were doing like A, B, C.
well, in a way, yes, but more numerical than letter. So we'll have a lot between 60 and 100. We won't have anything over 100, so it'll look like that. SAT scores and things like that. In fact, if we go back to Gaussian, there it is. They talk about, SAT scores, height distribution of adults, IQ scores, things like that. Height. So so how many adults are going to be 2'4"?
It's omega.
5 of them.
Every adult I know is.
So all we care is what the graph looks like, and what's going to happen on this homework assignment. Wow, time flies. What's going to happen on this homework assignment is we are going to be given formulas. And all we're going to do is plug into those formulas. No, you don't need it. You don't need it.
Oh, okay.
But I want it.
So I'm going to show you a couple of different homework type of problems. One in particular that I want to spend a little bit of time on. The others we'll get through pretty quickly. Okay, how about number 16, the growth of phytoplankton?
Photoplankton.
Phytoplankton. In Arctic waters, there are an estimated 50, okay, I really need the last 8 minutes. In Arctic waters, there are an estimated 50 million phytoplankton. The growth rate is 12% per month. How many phytoplankton will there be in 3 months? Utilize the formula n equals n sub 0 e to the RT, where n represents the population of phytoplankton. Have you ever seen a formula like this before?
Yeah.
Hopefully. What does that look like? Compounded continuously. Looks exactly like it, right?
Awesome for physics.
So you could probably figure out what to put in here. So n equals,
50.
n sub 0 is going to be 50 million, so we'll just write it as 50 and we'll say that our answer is millions at the end. E to the
Point.
point 12 times 3. Type that into your calculator, you're done. Problem over.
Oh.
No more than that. Almost all of them on this page are going to be that type of a thing. You see n sub 0 e to the RT here. If you go over here, you see n sub 0 e to the RT up there. You see the same thing over there. Okay. Where are we? I lost. You got it there, stuff like that. So you're going to see, basically we're giving you the formula all the time. You got to plug some stuff in. There's one that I want to show you that is going to take a little more work. And we'll talk about this and go through the problem so we can show you what's going on. Okay? We're going to talk about Newton's law of cooling. So let me ask you this. You toss something in the microwave to cook it. You take it out of the microwave and it is hot. You put it on the counter, you let it sit there for 3 hours, and the temperature remains exactly the same as when it came out of the microwave, correct?
No.
No. Because it